Alright, we just finished looking at some problems in which the function, remember, did not exist at a particular value. That's, where we had our open circles. But yet, even though the function didn't exist, we were still able to determine a limit. But as I just mentioned, it is possible that your limit does not exist, and that's actually what the three things that I have listed here. So you need to make sure that you are aware of these three situations. So I'll just read these real quickly. You will need to copy them down, but then I'm going to show you an example of each. So this is going to be the behavior associated with your graph as to when a limit does not exist. So the first thing is if your function approaches a different number from the right side than it approaches from the left. So as I've been mentioning, looking at it from the left side, looking at it from the right side, it's got to be approaching the same y value. Remember, your y value is your limit, okay? If it doesn't approach the same value from both sides, then your limit is not going to exist, okay? Second thing, if your function increases or decreases without bound, okay, what that's going to mean is your graph turns and goes up forever. Of course, remember, your limit is y. So if your graph turns and goes up forever, goes off to infinity, then there can't be a specific number that is your answer, okay? Of course, that would be increases. Same concept if it turns and goes down forever, there's not a particular y value that it's getting close to. So if it goes up forever or goes down forever, that means it increases or decreases without bound. Your limit wouldn't exist. And then the third option, or the third situation, is your function oscillates between two fixed values. So oscillate means it goes, from one value to another value, back to that same value, back, it bounces back and forth between the same two numbers, okay? Like I said, I'm going to show you an example of each of these. All right, so the first one I have is actually where your graph approaches different numbers from each side. Okay, so the function or the limit that we have here, we have the limit as x approaches 0 of the absolute value of x divided by x. And of course, I've already said here the limit doesn't exist. But when you look at the graph of this function, this is the graph of that function. Okay, so you're asked for the limit as x approaches 0. Okay, just ignore these little these are some Greek letters, don't worry about those. But this is where your x value is 0. So you're approaching 0 from the right and from the left. Well, if you look at it from this right-hand side, as you follow your graph, the y value that you're getting close to is right there, which is positive 1. Then if you follow your graph from the left-hand side, you have to come down here to do the left-hand side. And as you come in closer to 0, you're approaching right here, which this value is negative 1. This value, remember, was positive 1. So what you're approaching from the left and the right are not the same. So that would mean that your limit does not exist if it approaches something different from each side, okay? Of course, that's the explanation that I've written down here at the bottom as to why that limit does not exist, okay? All right, the second situation, remember, was where your graph increases or decreases without bound. So here's an example of what that means. Okay, we have the limit as x approaches 0 of 1 divided by x squared. And again, I've already said here the limit does not exist. So if you were to graph 1 divided by x squared, this is the function. This is the graph for this function. Again, they've chosen to approach x equals 0. So of course right here is x equals 0. So if you look at the right-hand side and you start tracing your graph on this right-hand side, as you get closer to your x equals 0, what happens to your y values? They just keep going up and going up and going up. Of course, that arrow right there means that it just keeps going up forever. Same thing happens on this side. As you approach from this side of 0, your y values just get bigger. Like it's at 1 and 2, 3, 4, your y values just get bigger and bigger and bigger. So it doesn't matter whether it turns up forever or turns down forever. In either case, this would be where your limit would not exist. Okay, and again, this is just an explanation of the fact that it, of course, here it increases without bound. Okay. Now, the third situation where it talked about oscillating between two fixed numbers, this is an example there. So we have the limit as x approaches 0 of sine of 1 over x. So if you were to graph this, again, you can graph it in your calculator, but this is what your graph would look like. Of course, right in here, of course, it all ends up getting messy looking here in the middle, but, you know, right here would be your x equals 0, which I can't. Let's see if this red shows up. Not really. Anyway. Right there, of course, you know, would be, here's positive 1, so here's 0, here's negative 1. So if you start looking at your graph from the right-hand side of 0, so I'm going on the right-hand side of 0, and I start following it, here's what happens. It comes down here to negative 1, goes up to positive 1. Then it comes down to negative 1, and then it goes up to positive 1. And it just keeps bouncing back and forth and never zeroes in on going to one particular number. It's going from negative 1 to positive 1, negative 1 to positive 1. And the same thing then happens here. As you look from the left-hand side, same thing. It comes up here to positive 1, comes down to negative 1, goes up to positive 1, goes down to negative 1. So that's what it means by an oscillating behavior. Okay, so this one oscillates between 1 and negative 1 as you get closer to x equals 0. So that would be the situations in which your limit does not exist. So make sure that you know those three situations.